Welcome, everyone, and thanks for joining us for the first American Chemical Society Agrochemicals Division Lunch and Learn webinar of 2026. This webinar series is made possible through the generous support of our new sponsor, JRF Global, and we sincerely appreciate and welcome their sponsorship. I'll be talking about this more after the webinar. I'm Salito Sumalong from the American Chemical Society Division of Agrochemicals Executive Committee, and I'll be your moderator today. Before we dive into our talk, I want to take a moment to talk about something that makes webinars like this possible, our agro community. If you're not already a member, I would strongly encourage you to join. Membership is the best way to stay at the forefront of the field, expand your professional network, and directly support the groundbreaking science that you see right here. You can add agro to your ACS membership or join as an affiliate for just $16 a year. It's a fantastic way to invest in your own career and our scientific community. Simply visit agrodiv.org and click Become a Member. And a quick updates. And some quick updates for you. Mark your calendars for the next ACS Fall National Meeting in Chicago in August. Please reach out to Dina Barrett for any questions. You have her information there. Lastly, the Agro Division is committed to building future-ready resources and engaging our members. Please, we need your help to continue to grow and succeed. Please visit agrodiv.org to learn more and get involved. Just a quick note on our format today. Please use the Q&A tool to submit your questions, and we'll be sure to address them at the end of the presentation with time permitting. While you're listening, feel free to introduce yourselves in the chat. Let us know where you work and what you do. We'd love to hear from you and to continue to network in our live events. A quick word on ACS community standards. We want to ensure a safe, collegial, and positive environment for everyone. The full text is displayed on your screen, but the main takeaway is simple. Please keep all interactions professional and respectful. This is especially important for the chat and Q&A tools. Any behavior that is harassing, threatening, or discriminatory is unacceptable and will not be tolerated. Thank you for helping us create a great experience for all our participants. Now it's my pleasure to introduce our speaker, Bansri Dhankecha. She serves as a junior research officer and study director in the ecotoxicology section of the Department of Chemistry at Jai Research Foundation. She specializes in both aquatic and terrestrial studies, contributing to research that advances environmental safety and ecotoxicological science. With over 3 years of experience in the CRO industry, Bansri plays an active role in the validation of ecotoxicity studies and is skilled in handling difficult test items. And with that, let's hand it over to Bansri at 9:30 p.m. in India. You're on mute.
Hello, everyone. Thank you so much, Solito, for your kind introduction. Hello, everyone. As Solito introduced me, I am Bansri Dhankecha, and I am working as a junior research officer at J Research Foundation, and I am a study director in aquatic and terrestrial ecotoxicological studies. Today, I am presenting overview of the various kinds of honeybee studies conducted at J Research Foundation throughout the year. So let's begin with the presentation. During this webinar, you will know about J Research Foundation, maintenance of honeybee colonies, life stages of the honeybee, various kinds of honeybee studies offered by J Research Foundation throughout the year, study designs, and some key takeaways. So let's begin with the introduction. Apiculture research in India, especially in South Gujarat, Bee farming is a well-known in South Gujarat region of India because of its having a rich biodiversity and humid climatic condition. Uh, and this region serves as an important tribal development hub. In Gujarat, especially districts like Tapi, Valsad, and Dang have a rich biodiversity and humid climatic condition for the beekeeping, and this several programs regarding the beekeeping, such as the Bee for Poverty Reduction under the Mango Tree Society, Mission Bee, implemented by the Amul Dairy, have successfully completed. Under the Mango Tree Society, is established around 2006, and by this society, farmers of more than 175 villages of Gujarat, Maharashtra, and Madhya Pradesh state have gained training on beekeeping. These regions also have a diversity in vegetation. They also receives high rainfall during the monsoon seasons, which provide bees a continuous and abundant food source. Continuing the introduction portion, let me give you a brief overview about J Research Foundation. So as you can see in the image, this is our campus, J Research Foundation. Just beside our campus, we have a flowing river named Daman Ganga. J Research Foundation is located in Vapi. Vapi and its surrounding area falls under the Valsad district of Gujarat state. Valsad is famous for its fruit farming, especially for the mangoes and chikus. So we get the food throughout the year. Here our ecotox section is located, and here over here we are maintaining the honeybee hives for the studies. We have a varieties of crops, flowers, and nurturing in our surrounding areas, which is grown by the surrounding villagers. In our campus, we have a varieties of plants. We have a lots of mango and coconut trees. We also have a nursery named Vikram Farm, in which we have varieties of plants. We also grow a seasonal fruit flowers for the bees for food source. And in India, season of autumn comes in between the month of October and November. During this season, temperature remains around 33 degree and rarely goes below 15 degree during the night time. So this temperature range is suitable for the beekeeping, and in South Gujarat, its climate is naturally favorable for apiculture. Its warm and stable climatic condition survives the bee throughout the year and provide a food source throughout the year. Now, maintenance of colony. We procure the colony from the supplier and maintain at our campus. We maintain the pesticide-free honeybee hives. We collect the bees from these hives to conduct the various kinds of honeybee studies. In a hive, if numbers of active worker bees, pollen, nectar, honey, and queen are present, it means it is a healthy hive. And the survival of the larvae is one of the most important indication of the healthy colony. One of our supporting staff also receives training on colony maintenance, who is monitors the colonies regularly and check the colonies. As we are maintaining this colony under the GLP compliance, it's ensured that each colony have a proper label with required information with unique identification number. As you can see in the image, this is the site where we maintain our honeybee hives. So moving forward, before I am going to explain each and every study design of the honeybees, it's need to understand why the studies on honeybees are required to conduct. As being in a preclinical research organization, we are dealing with large numbers of the chemicals. In most of them, there are agrochemicals and industrial chemicals, including the other kinds of chemicals. So these chemicals are used by the farmers to protect their crop and to remove the unwanted weeds and harmful insects. So these chemicals are sprayed for the to remove the weeds and harmful insect, which affect the production of the crop. But these chemicals also getting in contact with those beneficial insects such as the honeybees. So if when farmers are spray the chemicals on the field, the bees will go visit the field to collect the nectar and pollen. So indirectly they will also getting in contact with these chemicals, and the harmful effects like high contamination, bee mortality, and colony collapse is observed. So to identify the impact of those chemicals on the beneficial organism, it is required to conduct studies on honeybee, because the honeybee is a social insect and it is a very important pollinator for the agrochemicals. Now, before I start to explain each and every study design, let me give you a little information regarding the life stages of the honeybees. As we all know, a single colony have three kinds of member: the queen bee, drone bee, and the worker bees. Each of them having a specific role for the smooth functioning of the colony. Queen's work is to lay the egg and grow the colonies. Drone bee is met with the queen, and the worker bee doing the whole comb duties regarding the building of the comb, protection of the comb, and the food collection, etc. So on day 1, queen bee lays the egg in the hexagonal cell of the colony. A healthy queen can lay up to 2000 eggs per day under the favorable condition. And on day 4, these eggs hatches into larva. This larva is totally depends on the worker bee for their food source and for their development. Worker bee is looking over after the growth of the growth and development of the larva and regularly fed them. And this larva, now this larva goes into the pupation stage. During the pupal stage, worker bees cap the cell with the wax to protect the developing pupa. Now on day 24 or 22, this larva emerges into the adult bee. This adult bee emerges out by chewing the wax cap and joins the colony. Now, this bee officially becomes a member of the colony. After emergence, their first work to do is to clean the comb cell. This comb cell is used by the queen bee to lay the new batch of the eggs. From day 24 to day 32, they act as a nurses. They're looking over after the feeding and tending to the brood cells. This larva provides food to the developing larva. From day 32 to day 40, they act as a builders. Now these bees are able to produce wax from this abdominal gland. This wax will be used to build a new comb cell, repair the old ones, and to cap the cell of the developing larva for their protection. Now from day 40 to day 43, they will act as guards. They protect the beehives from the potential invaders. From day 43 to onwards, they leave the colony and go for the foraging. Now this became a forager's bee. They collect the pollen and nectar for itself and for the colony members. When they go for the foraging, they will getting in contact with the chemicals which are sprayed by the farmers over the field, and they getting in effect with those chemicals. So we conduct the study acute oral and contact toxicity test on the forager bees. When the forager bees coming back to their hive with a collection of pollen and nectar, this pollen and nectar will be used by the other members of the colony for their food. So this larva also receives that contaminated food with the chemicals. So it will also affect the growth of the larva. So we also conduct the studies on the larva by single and repeated exposure over this stage to emergence rate. And after emerging, the bee remains in the comb till day 22 to day 43. They will also consume the food which will be collected by the forager bees. So they will also getting in contact with those chemicals. So we conduct the honeybee chronic oral toxicity test on the newly emerged bees. So this division of labor observed in the beehive is very important for the smooth and smooth working of the colonies. Now moving forward, in Jai Research Foundation, we have a Apis mellifera species of the honeybee. By using this species, we conduct the various kinds of honeybee studies. Apis mellifera is a Latin word in which apis means bee and the mellifera means honey carrying. Various kinds of honeybee studies offered by Jai Research Foundation throughout the years include acute oral toxicity test, acute contact toxicity test, honeybee testing tier 1, honeybee chronic oral toxicity test by 10-day feeding, honeybee larval toxicity test by single exposure and repeated exposure. Here I have mentioned guideline numbers for the reference. We tried to conduct the studies on the all life stages of the honeybee to get the complete risk assessment of the test chemical on the honeybees. So let's begin with our first test, which is honeybee acute toxicity test. The procedure described here is common for both these studies, honeybee acute oral toxicity test and honeybee acute contact toxicity test. The day before the dosing or exposure, we collect the bees from the colonies which we are maintaining in our campus. While collecting the bees, we ensure that the frame which does not contain the larva and the brood cells are selected. We collect the bees in a polythene bag, and this polythene bag containing the bees are transferred to the laboratory condition, and it will be kept for the acclimatization. While keeping the bees in the acclimatization, the environmental condition will be same, which will be provided during the test period. On the day of dosing, first we prepare a dose formulation and then we expose the bee with this dose formulation. An observation is carried out at 4, 24, and 48 hours. The required environmental condition is maintained using an incubator. Now, validity criteria for this test are the total mortality in the control group should not exceed 10% at the end of the test, and the LD50 value of the positive control must meet the specified range. Here we are using dimethiot as a reference substance. Now, let me give you a little information regarding acute oral toxicity test. For this test, bees are kept for the starvation period of approximately 2 hours to get the same gut content. Meanwhile, we are prepared the dose formulation by dissolving the test item in 50% sucrose solution. After completion of the starvation period, we expose the bee with the dose formulation in a 2 ml syringe. The volume of the test solution is 200 microliter, and as mentioned earlier, observation is carried out on 4, 24, and 48 hours. As you can see over here, this is our test cage. Each test cage contains a label with proper information like a study number, test item code, treatment and replicate, date of the treatment. This is a 2 ml syringe in which we have filled and loaded the test solution, and this is how the bees are exposed with the test solution for the oral toxicity test. Now the second one is the acute contact toxicity test. In this test item is dissolved in distributor containing 280 solution and other suitable solvents. based on the property of the test item. Here, Twin 80 act as a wetting agent. Before dosing, bees are anesthetized with a brief exposure of CO2 for easy handling and safety purposes. And the bees are exposed with the test solution on the dorsal region of the dorsal side of the thorax region of the bee. As you can see in this image, this is a thorax region of the bee, and it is a micro applicator. By using this, we expose the bee with the test solution. We fill the test solution in this glass syringe and dose each bee individually. And the observation is carried out at 4, 24, and 48 hours. Now, the third test is Honeybee testing tier 1. This test is required for those chemicals which is having a microbial properties. For this test, the test item is dissolved in 50% sucrose solution. Bees are exposed with the dose formulation for a period of 24 hours. The dose level includes negative control, sterile filtrate, inactivated MPCA, and activated MPCA. Here, MPCA means microbial pest control agent. The bees are then observed for up to 30 days at an interval of 24 hours. After 30 days of observation period and the test, endpoints are calculated as LC50, LDD50, NOEC, and NOEDD based on the dietary doses. Now, honeybee chronic oral toxicity test by 10-day feeding. This test is performed on the emerged bee. Principle of this test is maximum 2 days old bees are exposed with 50% aqueous sucrose solution containing test item by continuous feeding period of 10 days. And the endpoints are calculated as LD50, LDD50, NOEC, and NOEDD values. Validity criteria for this test are the average mortality in the control group should not be more than 15% at the end of the test, and the average mortality for the reference substance group should be equal to or more than 50% at the end of the test. Here again we are using dimethiod as a reference substance. Now, test solution preparation. For formulated products, test item is prepared, test solution is prepared in 50% sucrose solution. But for the technical products and the product having the issues in solubilities, guideline prefers to use acetone to prepare a test solution. While when we are using acetone to prepare a test solution, it's ensured that the amount of a test solution should not be exist 5% in the final amount of feeding solution. Now, test condition. Bees are exposed with the test solution for a period of 10 days, and the observation is carried out daily up to 10 days at an interval of 24 hours. The required environmental conditions are maintained using an incubator. Now, one of the most sensitive tests we performed is on honeybee larva by single exposure and repeated exposure. First, we will begin with the single exposure followed by the repeated exposure. This chart is given in guideline in which we follow during the test period. For this test, some of the activities is performed in hive, and while the remaining activities is performed in the laboratory condition. From day -3 to day 1 activity is performed in hive. When the test activities start in the laboratory condition, this day is considered as day 1. On day -3, queen bee are inserted into the excluder cage, and in the morning. On the next day, the queen is released from the excluder cage in the evening time or afternoon. The maximum time the queen bee should be kept in excluder cage should not be more than 30 hours. This insertion activity of the queen bee into the excluder cage must be performed at least in 3 colonies, which will be act as a replicate during the test period. Now, during this period, queen bee will lay the eggs into the frame, and this eggs is hatches into larva on day 1. Now, this larva is ready for the grafting. Before grafting, it's ensured that the plates and the feed for the larva is prepared. As it is a single exposure, larva will administered with the test solution mixing with diet C will be exposed on day 4. And day 5 and day 6 of the test, the larva will be observed for the behavioral symptoms and mortality, and also required volume of the diet will be provided. On day 7, observation is carried out and the test is terminated. Now, principle of this test. On day 1, synchronized larva from 3 different colonies is grafted into 48 well plates. And on day 4, the larva will receive a single dose of test chemical. The mortalities are recorded on day 5, day 6, and day 7 of the test. And the 72-hour LD50 value will be calculated. Now, validity criteria for this test. The larval mortality in control plate should not be more than 15% across all replicates of the control plate. And the larval mortality for the reference chemical should be equal to or more than 50%. Here again we are using dimethoate as a reference substance. Now the second one is a honeybee larval toxicity test by repeated exposure. This test is similar to the single exposure, but larva will receive the repeated dose of the test chemical. Now, from day -3 to day 2 activity is same as the single exposure. But now as it is a repeated exposure, larva will receive the repeated dose of test solution with respective diet from day 3 to day 6. And observation is carried out from day 3 to day 8. On day 8, larva will be moved to the second desiccator and observation is also carried out. Now, the pupation stage of the honeybee will be started. On day 15, the pupa containing plates are moved to the emergence box, and here the observation is also recorded. Now the bee will start to emerge. So on day 22, the number of emerged bee, the number of non-emerged bee, and the number of dead bees will be recorded and the test is terminated. Principle for this test is on day 1, the synchronized larva from the 3 different colonies will be grafted into 48 well plates. And from day 3 to day 6, the larva will administered with the test chemical daily. The mortality and other abnormal behavior will be recorded daily from day 4 to day 8 and on day 15 of the test. The emergence rate on day 22 is also recorded. At the end of the test, the endpoint values are calculated. Validity criteria for this test is the larval mortality in control plate should not be more than 15% across the all replicates. And the adult emergence rate on day 22 in the control plate should be equal to or more than 70% across the all replicates. The larval mortality for the reference chemical should be equal to or more than 50% across the all replicates. And the dimethoate is used as a reference chemical. There are some common procedure for both the test, single exposure and repeated exposure over the honeybee larva. First one is a larval diet preparation. To prepare a larval diet, the 50% weight of fresh royal jelly and the 50% weight of an aqueous solution is used. The aqueous solution is made up by yeast extract, glucose, and fructose in different ratios. For each diet, there is some slight difference in the composition of the aqueous solution, which I have mentioned in the slide. The next one is the experimental procedure. This procedure is the queen insertion in the excluder cage. This white frame is excluder cage, and this from this little opening, we insert the queen into the excluder cage. This is how the queen bee lays the egg into the each and every cell of the colony. This white dot-like structure is queen eggs. This is how the larva appears. This one is a grafting tool. The anterior portion of this grafting tool is a very soft, which does not harm the larva. And by using this grafting tool, we graft the larva into 48 well plates. This is a 48 well plates with larva. Before grafting, we prepare 48 well plates in such a manner each well contains a piece of sterile cotton roll with 500 microliter of 15% glycerol solution. Over it, we place a sterile cup cell using a forceps. In this cup cell, larva will be grafted and diet will be provided. In this plate, orange color is of cup cell. Now test solution preparation. For the formulated product, test solution is prepared using osmosed water, but for the technical products and the product having the solubility issues, guideline prefers to use acetone. The amount of the test solution is controlled in the final volume of the diet. If we are using osmosed water, the allowable volume is 10%. But if we are using a acetone to prepare a test solution, the volume is 5% for the single exposure and 2% for the repeated exposure in the final volume of the diet. Now, some key takeaways from the presentation is year-round pollinator studies provide more consistent and ecological relevant data for the honeybee risk assessment. Continuous testing strengthens the scientific robustness and the regulatory defensibility of the pollinatory safety evolution. India's favorable climatic conditions supports us to deliver the studies throughout the year. And this unique advantages enables the generation of reliable, regulatory ready data that align with the evolving the global expectations, which will be used to submit the regulatory bodies for the product registration. Thank you so much for your kind attention and time.
Great. Thank you, Bansri, for your great presentation. So what I want to do is move on to questions, and we have plenty of time for those. So we should be able to take on the three that are in our question and answer tool, as well as a few maybe that I have in my back pocket. So first one concerns experimental design, Bansri, right? Hive temperatures, you say, are typically hovering about 34 degrees centigrade, yet testing is conducted at 25 C. Could you speak to the rationale behind the temperature choices and whether you have investigated how thermal variance might influence toxicity data? Is that a factor in your methodology?
25-degree temperature is usually commonly observed during the seasons. The guidelines gives a temperature ratio which is suitable for the bees. If the temperature rises above and falls below, honeybee can survive. 25-degree temperature is okay for their usually here in we optimum range guideline provide us, which is a 25 degree.
Okay, great. Uh, a good question came in about uh, microbial substances that come in for testing. Which method are you using to determine the microbial concentrations in the dose? So colony forming units, etc.
We count the total viable count, a CFU counting method to count the total viable microorganisms. CFU count we conduct.
Okay. Using any specific method for the sake of completeness on the question, is there a is there is there a method that you've defined for that CFU count?
We have one specific person in other section which performs all microbial studies and CFU counts. They gave us the data, and by using this data, we conduct the studies on honeybee. So regarding method, I will get back to you with later.
Okay, great, sure. Okay, that gets me to a question on we have a global audience here, Bansri. I think it would be an interesting thing to have us understand what it would be like to schedule a project with JRF Global, because it is really an advantage to test year round, because we can queue all of our testing into a shorter time period than would be possible, say, in North America. So what would be so can you walk us through the logistics and the scheduling of studies as well?
Sorry, I didn't get your question. What are you trying to
Sure.
say?
Well,
Right.
if a project manager from a client wants to schedule a bee study in a non-traditional season,
Okay, okay, okay.
how would we approach JRF Global to schedule that? And
Yeah, I get it. In India, we have climates that climate supports us. That in India, the bee colonies
right,
can survive throughout the year because here the temperature never goes below to 15 degree. In lower temperature, bees are not able to fly and go for the foraging. So keep in the colonies, and colony collapse is observed. But in here we have temperature never goes below to 15 degree, so bees can remain active and we can provide the study throughout the year.
right. That gets us to another question that was brought in, which was it was observed that do you see any adverse effect on the honeybee colony seasonally, particularly as the laboratory is in an industrial area? So winter versus summer seasonality.
No, 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 no. No adverse effect we observed here. Because in our campus we have varieties of plants, and the bees go for the foraging about 3 to 5 kilometers, and over this area we have a lots of vegetation during all the seasons. So bee is remain survive and keep active in all the seasons, so they will not getting in contact with this chemical.
Right.
So
Okay. Great. Radhika Davar had a question about, can you share with us any details of your limit study as well?
sorry, for limit
Uh,
study, conduct the limit
yes.
study.
Yeah. Can you?
Okay. Honeybee limit study is conducted at 100 μg AI per B dose level. Is based on the purity of the test compound. We select the dose level in μg per B and conduct the study with a control group and limit concentration level with the parallel with the positive control groups. That's it.
Okay, great. Hey, another question rolled in. Are you finding that clients expect to use the 8-day LD50 from the chronic repeat exposure larval toxicity study, the OECD 239, as a surrogate for the acute toxicity test rather than relying on the 237 by itself?
Honeybee chronic oral toxicity test 239 repeated exposure you are talking about.
Right. Are they going with that method rather than straight to the 237? Do you see do you see customers doing that?
Yes, we can offer a customized study as per the requirement, and we
Mm-hmm.
can either go by following the OECD guideline.
Okay. From Dilip CS, how frequently do you feed the honeybees on colony, and what feed do you provide? You mentioned a few things along the
Okay.
way.
So weekly we provide a feed to the bees. We give them a sugar syrup and also prepare a duff using a pollen and raw honey, mixing these two things and make a duff and provide each and every colony. It depends on the season. In summer season, bees go for the foraging, so it does not require much food because that time they remains more active, and by itself they will collect the food from the outsources. But during the winter season, we should provide more feed, and we regularly check if we feel that the colonies require the more feed. We are providing them.
Yeah. Okay. Great. Just a confirmation. The we're talking about year-round pollinator studies because of the climate and based on the location of the laboratory, and not necessarily that the bees are in a greenhouse, for example, and under controlled conditions. That's right. Is that right?
You again ask me the question. There is some network glitch.
Yeah. Right. This is basically a confirmation that the bees are raised in an year round in outdoor conditions based on the climate of India, and not because they were raised in a they were not cultured in a greenhouse or indoors.
Yes.
Okay. To follow back up on the seasonality issue, in temperate climates such as North America, uh, colonies lay down winter bees. Do you have any information whether there is a difference in sensitivity in the different broods during the season? Are the characteristics of each bee different from season to season?
No, there is no much difference. Just one difference is that in summer bee remains more active and go for the foraging, and during winter they go for the foraging, but during the noon time, early and late evening they remains in the colonies. So
Yeah.
there is no seasonal effects routinely.
Yes, we had a
So
big
so we
no in capital letters in the chat. So, all right. You mentioned acetone as a method for dissolving test substances that are a little harder to solubilize in water. Uh, do you have any other methodologies other than acetone to at least deal with that diet? Do you homogenize? How do you deal with microbials as well, right? In this context?
So other than acetone, we can use DMF, DMS, or other solvents. But before choosing this as a vehicle, we consult with the sponsor and also check the toxicity of those suitable solvent. Prior to the study, we conduct the research trial to get to know the toxicity of this other solvent, if they are having any effect, adverse effect on the uh, development or mortality observation. So before study, we check, and after we conduct the studies.
Okay, great. Our friend Keith Solomon, he's a regular watcher of our webinars, and I really appreciate his input and interactivity. Do you conduct whole hive tests under field or semi-field conditions, or not?
So no, till now we are not conducting the study on the hive. We just
Okay.
do
Okay.
the lab studies.
Right. Matthew Labor has had an interesting question about disease vectors. Are there issues with Varroa or other disease vectors when selecting eggs and larvae?
Sorry, I didn't get you.
Are there any issues with diseases such as Varroa mites? And are they screened for that? Do you have a screening protocol? And
No, no. Here we can't. We are not. I don't observe the disease in the bees till now, and it's not.
okay, no issues
Because we
currently.
regularly check the colony and maintain the hygienic condition for the beehives. So it's not chance to get the disease.
Okay. What do you look for necessarily? Mortality when it comes to maintenance of the hives. Do you look at mortality? Do you look at general environmental conditions, etc.?
We check for each and every frame of the bees. We check the larva, eggs, bees. Is queen bee is present or not? Sometimes it's happened that the queen bee fly and the colony collapse has been observed. So we check all these parameters, and we also check if the
Okay.
another
Yeah, obviously that's a
insects and
factor
all the things is
with that.
present or not, and the cleans the comb cells. Sorry, comb cells. Nahi. We clean the comb. And provide the food for the bees. In routine checkup, we do all these things.
Okay, great. So how are you measuring the analytical verification of exposure? I know we did talk a little bit of about colony forming units. Do you measure the residue in each treatment solution?
We have an analytical team for that portion. We prepare a test solution and send them for the analysis, and they analyze the concentration, recovered concentration.
Okay. Now, Dilip had a follow-up question on handling honeybees, right? And during an inspection. Uh, uh, are you the one handling the honeybees? I heard you have a big veteran on staff
Yeah,
that handles that.
the picture you have shown in the presentation was me. I'm
Okay.
handling the honeybees with wearing a proper PP and with gloves and all that things. Handle the bees gently took out the frame from the hive and observe.
Okay.
And this observation is we done is on the early morning and the late evening, because that time the bees are not much active. During the noon time they are more active, so that time it's not suitable to visit the beehives. So during the morning and evening we check the colonies.
Okay. Right. Uh, Two more questions have rolled in about specific as you've been observing the health status of the bee colonies. Uh, what would be the protocol for any found vector disease such as Varroa?
Sorry?
If your colony does have Varroa, do you treat all colonies in your yards that the population experience the same baseline exposure before putting them into a study? How do
Till
we treat?
now,
Yeah.
okay. Till now, we didn't observe any honeybee disease, but if it happens, we separate the colony from our where we are maintaining the other colonies. We separate those affected colony and keep it aside, and
Right.
and the bee have a one special characteristic. They does not go to the another comb. They will only visit the whole on comb. So it will not affect. If the one colony is affected, they cannot affect the colony which is besides them. So this is the
Okay.
advantage.
So we mentioned bee health conditions. Are you specifically monitoring Varroa mites or any other vector species such as Tropilolaps or Nosema?
No, disease is not observed here. Only the invaders like wasp sometimes observed. So we do that. We empty the whole comb and shift the frames into the another one and clean whole the colony. That's it.
Right.
We shift the frames with the bees in the another comb and clean the old one.
Great.
And for ants, we kept the vessel filled with water so the ants cannot climb up to the colony. So
Hmm.
it's not.
Okay. Right. I think we've been able to get through. Oh, a follow-up question on that. What physiological markers can be used to assess larval health? I mean, you have mortality, we mentioned that, but any other physiological markers? Any other symptomology?
In colony, we are not observing but during the studies, because of the test chemical, the larva became the black and the straight became the straight, and the uneaten foods is also observed during the test period. So these are the symptoms observed, like ataxia and all things.
Uh, David Miller asks, can you say anything about the stat tests used?
Sorry?
He might need to elaborate on stat tests.
I didn't get you. For state,
Oh,
you are talking.
statistical tests. Sorry.
Okay. We have
Thank you,
a
David.
industrial software tox rate. By using this tox rate, we calculate the LD50 and endpoints values.
Okay. Thomas Steger once again. Are you evaluating food consumption in the chronic larval toxicity test? And how do you measure bee weight upon emergence?
We just check the larva is consumed the food or not. We didn't measure the amount of the food which larva is contained or not. Just make an observation that is if it is consumed by the larva and if it is not consumed by the larva, and that will be recorded. That's it.
Okay. Do you measure but not the emerged weight of the bee
So larval
as it
study,
moves
the
throughout two?
amount of the food consumed is not required. Thus, we make an observation that it is either consumed or not consumed or not. That's it.
Okay. In lieu of that, in the place of quantitative data in terms of weights, do you uh, do you measure the weight of the bee after it emerges?
No.
Okay.
They didn't get the bees after emergence.
Okay. Are your colony bees foraging on the local floral population? And then, if so, do you analyze the pollen to determine if the nutritional quality is uniform across the different colonies? So I could see.
So,
So if a colony if one colony forages on one species of floral population and something's different, do you can you determine
no,
that difference?
no, it's all colony are similar. In our
Okay.
in our campus, mostly the coconut and mango trees are there. So the bees will be collect the nectar and pollen from that. So coconut pollen and mango pollen is outside.
Okay. Great.
No difference
And,
between the
yes.
colonies.
And we'll go with one last question here, Bansri, and you've been fantastic with my with my lack of diction. So, uh, are there any preference on limit versus repeat exposure studies? And how do you guide your clients about which method to move ahead with from your perspective?
What are you
So, if
trying
you
to
had
say?
do you guide your clients on whether you design a limit test study or a repeat exposure study?
Generally, the standard requirement is a acute oral and acute contact toxicity test.
Right, at the limit, at the upper
100
limit.
mg AI, 100 mg per AIB is based on the purity of the test item. We conduct the
Mhm.
study at 100 mg AI per B level. That's it.
Okay.
But if the regularly required the chronic data, so we conduct the study. If in some chemicals the chronic data is required, then we conduct the chronic studies.
Okay, great. I'm going to close it up here uh, and present my final screen here. Great. Bansri, you've been fantastic. You were great on our presentation. Uh, thank you again for your excellent presentation. And of course, to our tech host, Kyle Sawyer, and to JRF Global for their generous sponsorship. We could not have been able to get the active and enthusiastic support from JRF without my colleague, Columbu Malakani from JRF, and the Agro Development Committee headed by Andy Newcomb and Ralph Warren. This has been a 5-month process, and we're excited to collaborate with them, get to know JRF Global a little bit better, and to continue the fine work we've been able to accomplish with this series over the years. We'll be posting answers to any unanswered questions, so please keep looking for a follow-up email that should also include a brief survey. I do need to set up the interface there. About our 2026 webinar series after today. The next webinar will be on May 20, featuring the Austin, Texas company Vivoverse on alternative test methods for developmental and reproductive toxicity. We're planning content, continuing the Agro and ACS Award Winners series in September. And we're also continuing the HIST division co-programming for ACS's 150th anniversary. So to join the webinar committee to moderate, for assistance with communications, so to spread the word out to all of your friends, and publicity, and to also program 2027, please email me. So thank you all for your participation today, and we hope to see you on May 20th.